Okay, hello everyone. Good evening and welcome to this workshop on space robotics organized by SpaceOnova and SEDS-VIT. Before we start, here is a short introduction of the organizers. SEDS, which stands for Students for the Exploration and Development of Space, is a global student-run non-profit organization and aims to promote interest in space exploration among students across the world. SEDS-VIT serves as the headquarters for SEDS India. We are here with SpaceOnova, which is a space education and research-based company with an aim to establish an ecosystem where anyone can learn, create, innovate, and impact. Having already inspired more than 32,000 space enthusiasts and professionals across 39 countries, they aim to create a global community of space exploration. So this two-day workshop, as we mentioned earlier, is on space robotics, and the instructors are Mr. Shivam Kumar Singh, the founder and director of SpaceOnova, and Mr. Sautik Nandi, Chief Information Technology Officer of SpaceOnova. So without any further ado, I'll hand it over to Mr. Shivam Kumar Singh.
So thank you so much, SEDS-VIT, for giving us this opportunity to interact with your community. So first of all, hey there, guys. I hope I'm audible to each and every one of you. And if you're excited for today's session, just write boom in the chat section and I will know that, yes, you guys are there, all present behind the cameras and, excited for it. Anna, Akshar, Tushar. Cool. Awesome. Okay, awesome. So without any further delay, let's start with the session. I will present my screen. Let me know if that is visible. I will just present it now. Is it visible to all?
Yeah.
Awesome. Cool. So once again, guys, welcome to Introduction to Space Robotics, our today's session. And tomorrow we'll cover introduction to ROS, those who wants to, take it further and etc. And with that, I'll just come back to my screen and say hi to your bot here, right? So this is your little soundbot, would be supporting you all through the slide today. Moving forward, and also let me know if my pointer is visible to all of you. Is it visible?
Yeah, it's visible to us.
Okay, so once again, like a little bit about SpaceOnova. So at SpaceOnova, we have a dream, a vision that by year 2025, we want to make sure that each and every child of this nation should have enough resources and guidance to be able to pursue careers in the field of space sciences, irrespective of their background. So just like Dr. APJ Abdul Kalam stated his vision 2020, we have stated ours. Now, the only question is, are you guys with us? If yes, let me know that through your contributions to the space ecosystem, and let us make this nation and this world a better place to live in and become a spacefaring civilization. SpaceOnova stands in 4 foundational values, that is love, transformation, cosmic, and innovation. And that is why it's a place where limit tends to end. Let us come to the second part. Before even moving on to the technical part, we'll discuss a little bit about the careers, how you can get into the industry, and how you can use your existing network to actually take your first step. And as the line says, that your network is your net worth, right? So it's quite important that we start with networking, we start with knowing each other. So I'll just ask Sautik if he is here to post his link in the chat section, or else I will share it.
Yes, sure. I'll just go ahead and okay, perfect.
Yeah. So you guys can just go to this link, on the link, just comment down who are you and why are you interested in space robotics, or what do you want to explore in this field of space robotics, because space robotics is vast, right? And after this session, you guys can take a little bit of times and try to go and DM that person, try to collaborate with each other, and take your journey further. So I will share this link in the WhatsApp group also, so that you guys can access it easily from there. I think it's there. Yeah, awesome. So take 30 seconds. Quickly, you guys can start. Can you come again?
No, it's all right. You can continue.
कन्विंस नहीं करना है, he will कन्विंस हमें होना है कि हम कितनी जल्दी कर सकते हैं.
Okay.
Yeah, you can continue, sure.
Okay. Yeah. So you guys can take 30 seconds to just go on and give your introduction there in the LinkedIn, and then you guys can try to network with each other. And trust me, it will work in a really good way, because there is a small surprise for you all. There would be a lucky winner for our upcoming space robotics training program, which we would choose from the various comments which where we are conducting this workshop, and that one lucky winner would be awarded the training program for free of cost. So do and try your luck out there too, right? So moving forward with our session, that is how to kickstart your journey, right? So as I first mentioned, that it is networking. So this is just me with UAE's first space astronaut, whom I networked with in our last conference, IAC 2021.
Sure. Sorry for interrupting, but I think the screen just went off. Could you just go ahead and present your screen again, please?
Okay. Am I audible to you?
Yes, you're completely audible. I think due to some issues, the screen presentation just went off completely.
For some reason, it's showing that you're not allowed to share your screen. I don't know, someone.
Yeah, I think now it's available. Right.
Is it visible?
Yes, it's completely visible.
Okay, so yeah, I was just showing you that this was me with UAE's first astronaut. So we just met him in the last conference in ISC 2021 in Dubai itself. So networking is quite important, and conferences are one way to go for. And if you cannot go there, then LinkedIn is your best way to start with. So after networking, you guys can try to upskill yourself. So try attending some training programs, or maybe take up some courses or elective courses you might have in your college, or maybe Coursera, Udemy, or you can come to Spaceonova, obviously, right? So take up some training programs to upskill yourselves based on whatever plan which you have made for yourself. Suppose if you want to be a space systems engineer, then try to take up certain courses to understand the subsystems of various rockets or satellites, or how does mission designing occurs. Try to learn the softwares and etc. So upskill yourself. Go on to write in your independent abstracts and submit in international conferences. So there are conferences like International Astronautical Congress, which is held every year. If you're specifically interested in astrobiology, then there are conferences like AppSciCon, AppGradCon, which are supported by NASA. And there are many such other, well-known space-themed conferences which you can participate in. IAC is, if suppose your interest is like, very broad, then you can go for IAC, because it's one such conference where, no matter which field of space you are from, you will have certain symposiums where you can submit your abstract to, right? So those who don't know about the conferences and the concept of conferences, let me just quickly explain that to you. So basically in conferences, what happens is you can submit an abstract that is just like 200 words para and stuff like that. You don't have to write the whole research paper. If your abstract gets selected, then presentation or a lightning talk or maybe poster presentation on that particular topic in which you have jotted down your abstract in on, right? And then it is up to you. Suppose if you get a chance for oral presentation or even an interactive presentation, it is up to then complete writing a research paper on it. And if you want, you can do that. And if you need mentors, these people even provide you mentors, right? And in research and etc., you can even reach out to Space Nova for such help. So do submit those abstracts, attend those conferences, and it will help you so you can get to meet literally all those high profile people in space, starting from astronauts to space professionals. Even you can network with your fellow students out there. You can collaborate with them. You can seek internship and job opportunities. You can work on interesting projects and etc. So do go for such conferences. After that, you can also try to seek some internships in existing space companies or participate in space theme competitions. Through that, you will get more exposure on how to build your product or solve a particular problem existing in the space industry, and it can help you come out as a problem solver in this industry and become a better engineer or a better innovator. And Space Science Challenge is like one such challenge which Spaceonova conducts every year. We initiated it last year, and this year again we have launched it. So you guys can even participate in that. We have three categories. Those are rockets, satellites, and space. You can also try to learn foreign languages because foreign language will help you getting into higher studies or some jobs in those particular foreign country like Germany or France and etc., right? So you can try to learn either German, French, or maybe Spanish, which helps you in getting a job in your desired country or the location. So try to learn a foreign language whenever you get time, and by following these steps, it can help you to kickstart your journey in the space industry. And trust me, these are very simple steps. It might look very difficult, but it will just take like 1 or 2 years of time you need to spend, and you can cover all of them, right? You can start with networking and training programs for quarter of an year. At the same time, you can submit your abstract into a conference for the next year. Try and experience by participating in a challenge, and then by end of the year you can learn a foreign language, and by the second year all your hard work will start showing the results. And this is just a picture of a boy who is really in right now he might be in 7th standard, I think. Last time he was in 6th standard, and he actually won first prize in our last year's Space Science Challenge despite his age. Many people participated in that Space Science Challenge, from undergraduates to professionals and etc. And the judges were from ISRO, JAXA, and various other space companies. And I just wanted to show his picture to you guys just to inspire you all that if this kid can do it, then even you guys can. Okay. Moving forward, let's start with our technical topic today: space and robots, right? So guys, robots have multiple applications on Earth, like in factories, medical, nuclear plants, bottom of seas, disasters and war sites, automobile industry, etc. But what are the applications of robots in space? Can anybody tell me? Like, you can even see the pictures from here, so you can just enable your mic and say. Hello, anyone? Like, what are the applications of robots in space? We know what are the applications on Earth, but what about space?
Sir, to explore and study the space. and get a better understanding
Okay.
of it.
Space exploration. So deep space exploration is one thing which Srijani has mentioned. Cool. Uh, Mohit has mentioned interplanetary exploration. Yes, so same thing, deep space exploration. Other than that,
Data
you
collection.
yes, so Bharadwaj is mentioning data collection. So data collection now can be from either the surface or from the atmosphere, and any part of that particular planet. So data collection is one thing. Good. Anything else, guys?
Sir, by robotics, we can study the where humans cannot go, and we can study them.
Yeah. So exploration has been already mentioned. So other than that, answers are there in the screen itself, guys. Just look at it and tell me what is it.
Can be done.
Exactly. Like, any idea?
Machine maintenance. If any maintenance like that.
There are many space stations where they repair in many.
Yeah, yes, we need maintenance on space stations. We need maintenance for satellites also, right, which are already there in orbit. We need to maintain them. It does need servicings. There are space telescopes which need servicings, right? So these are few of the examples. Yes, Mohit has mentioned Hubble telescope. It was a blunder. I will come to it later in the challenges part. But yeah, these were few of the examples that when we talk about deep space exploration, like exploring asteroids or comets, other planets like Jupiter and Saturn, there we need robots, right? We do send probes and other sort of robots to explore the deep space. Then there is survey for planetary surface. So for example, if we want to create a habitat on moon or Mars, we need to understand them first, right? So we can start with understanding their surface, like what sort of minerals are there, do we have any water out there, and stuff like that, right? So that is there. Then assembly and construction. So if I really want to create a habitat on moon and Mars, I should be able to use their minerals, use their soil and etc. To construct stuff, to construct structures where I can live in. But how to do that? Not humans cannot really in the space suits, we really cannot control those small screws and stuff like that, or maybe we cannot control few stuff which is which there are limitations, but we can use robots to do those assembly and construction work. Then, for as we already mentioned about satellites, the servicing and maintenance of in orbit satellites. Then robotic landing. So you guys are already familiar with SpaceX. How they use the same launch vehicle again and again, right? So they're trying to recover it, and when they recover, they have landing legs, right? And that uses basically your robotic technologies, right? And for satellites also, as I already mentioned, like when they run out of fuel or when they need servicings, we use robots in that also. So these are few examples basically, and we'll discuss them in detail. Basically what are the various other challenges and etc., and what other sort of robots are there. But before moving to that particular point, why do we really need a robot? First of all, why cannot just humans do all that, right? Like, why only robot? Why not maybe just some mechanical system which is not robotic? There could be some other ways also, right? Like, why robots?
Sir, because like in, for example, Mars is a best example for that. We cannot go easily over there, and so that's the reason why we send robots to analyze the planet and study the whole planet.
Yeah, and even more than whether we cannot go there or not, we can obviously, like, if we can send robots, we can even send humans. But the major problem or the major answer to all that questions is the harsh and
Humans have
extreme
many
environment.
limitations, but robots has not that limitations. So we can use the robots where humans are limited.
Exactly.
Problems
So
if we humans have many limitations. If we send them to space, so the work quality of robots will be better than humans.
Yeah, Abhishek, I'm coming to all these points. So basically, I'll start with the first point, that is the environment in space is harsh and it is very extreme, right? So in those extreme environment, it's hard for human to work. It's not that human cannot do good work or human cannot reach a particular point, but the conditions are very harsh. It is not really favorable to us as a living being, right? And for that reason we want robots to do as much of the work as they can do in those harsh conditions, right? So let's try to discuss each of these challenges one by one. So obviously, as I mentioned, space is hostile. We have microgravity, we have space radiation, extreme temperatures, plus there are difficult tasks, right, which humans cannot really perform, like construction of habitats, on orbit servicing, infeasible locations. So if a satellite is already orbiting, space station is a different thing, but what about other sort of spacecrafts which is orbiting us? We cannot really go and have an on orbiting servicing. It's quite so it could be life threatening in a way, like so spacewalks are not like that what do you say, exciting how much it seems. It could be very dangerous if we go for spacewalks frequently. So we have certain difficult tasks like that. Moving forward, cost effective is cost is basically another problem, because whenever we send humans for any sort of servicing, as our one of our friend mentioned about Hubble telescope. So Hubble telescope took around 5 servicings, right? So when we send to space, or basically the astronauts to work on certain stuff, it is a very costly mission, right? Deploying robots are basically less risky and it is cheaper than launching humans into unknown environments, because we don't really have to worry about their safety. We do need to protect our robots, but we don't have to worry about its death or stuff like that. Then mental state, in space, working in space could be very isolating in nature, and it comes with a lot of medical issues like skin diseases, wounds, and dental problems and all that stuff. And as I already mentioned about isolation, and those affects also, because astronauts are usually they stay very far from their family for a very long time, so it does affect their mental state a lot, and they can't even get a hug properly. So yeah, isolation and long duration space flights can cause mental breakdown in humans. So these are the reasons that why we go for robots in space. Very simple, the space is hostile, there are difficult tasks, it could be very expensive sending humans to do a certain task, and mental state. These are the reasons that we want to talk about. Moving forward, what are the working areas of space robots? So we can basically divide them into two types. One is orbital and another is planetary robots. So orbital robots, are the ones which are used for basically, as I already mentioned about satellites, the orbital operations in space, moving the space debris, and for microgravity research. Then there are planetary robots, so basically probes for collecting scientific information. Those robots are basically office, or maybe we can have some sort of flying sort of robot. So there are multiple type of planetary robots, we'll come to it. And these are basically could be precursor of any human missions. So for example, even now in the Gaganyaan mission, when ISRO is trying to send a spacefaring robot which is known as Vyomitra, right? So before sending to humans, it is sending Vyomitra to understand the environment, and what sort of whatever information which they will collect from there, it will help them to better get them ready for sending humans in future. So as I already mentioned, so planetary robots are basically the precursor of future human expedition to remote celestial bodies. And moving forward, it's a trivia time. So can you name any, any of the first space robots which was ever deployed? Anyone? You can write it in the chat section. Any first space robots you know about? Bharadwaj, Curiosity is still working, so it's one of the current robots. Sputnik is a spacecraft, not a robot. Insight, okay, but it's not one of the space like first space robots. Insight is a rover, yeah. Yeah, it was sent by Soviets. Rajdeep, you're correct. The first space robot, was sent by Soviet Union. But what was it? Surya has mentioned Sojourner. I don't know if I'm able to pronounce it right or not, but yes, it is one of the first, like see in the series of first space robots, but it is not the first space robot exactly. At least, can you guys mention what type of robot was the first space robot? Was it an arm? Was it a rover? What type was it? Can you mention that? Abhi mentions rover. Vikram mentions planetary robot. Someone mentions Voyager. Guys, spacecraft is different and space robot is different. Okay, so yes, those who mentioned about the rover, you guys are correct. So I will come to it. These are, are one of these space robots, and as usual, Soviet Union. Because see, so basically, due to that Cold War, these technologies, the Soviet Union, they were the first ones to basically send a space robot, and it was to the moon basically. So Luna Khod 1, that was our first ever space robot sent to the moon, and these were the result of space race to explore the nearby celestial bodies. And this first space robot, Luna Khod 1, it was developed by Soviet Union, and it traveled quite a lot of distance on the moon, and it was very simple. It just had wheels, it had cameras, it had antennas and stuff like that, and it used to just send images. That's it. So it was a result of the Cold War, and it was a very simple space robot. But yes, it was the first space robot, Luna Khod 1. It was sent in 1970. Then there were other missions like Viking 2, Robotics. Then I'm not able to pronounce it correctly, but Sojourner, I don't know what is its correct pronunciation, but yeah. So there were many missions like this, afterwards, which were mainly by NASA then. Like Viking 2, Robotics was developed by DLR. Then there was this famous mission named as Venera. Now there were, I think, around 10 Venera missions. It was basically to the Venus, and it was Venera 9 was the successful one. Previously, most of them failed. Even the initial Mars missions, they were quite a failure because these were for the very first time. But Venera 9 was a successful one mission to the Venus, and I think it melted within 70 seconds or something like that, because Venus has a very harsh environment. The atmospheric pressure is also quite high. If I'm right, it is like around 100 bar, like 100 times the atmospheric pressure compared to Earth and stuff like that. So, but it was a successful one, Venera 9. It did send, it did fulfill its objective and stuff like that. And the most interesting one is the moon buggy. I don't know how many of you know about it. If you do know, then you can just write it in the chat section or enable your mic and speak. Anyone who knows about moon buggy? It was quite an interesting robot at that time. Anyone?
Yes, sir.
So basically, it was part of the Apollo mission itself. though many people they know about Apollo 11 mission, they know about Neil Armstrong, they know about Buzz Aldrin and etc. But there were further, there were more Apollo missions after the successful ones, the famous ones, basically, I would say, which you already know about, right? And in one of them, there was this moon buggy, in which it was nothing but it was it was a robot which astronauts used to drive around the moon. So if you have a wild dream to go to the moon and drive something there, so it has already happened. And it has been named as Moon Buggy, the vehicle. Someone is mentioning today is Buzz Aldrin's birthday. Oh, I didn't know that. That's great. Good occasion then. So yeah, this was about the Moon Buggy and some of the first space astronauts. Now, again, moving forward with our technical parts. Now, when we talk about what are the various researches which are being, currently going on in space robotics. So the major three fields which people are exploring right now are the mobility and locomotion, autonomy and intelligence, sample acquisition, analysis, and delivery. So basically, see, the research domain for space robotics is very vast. And I'm just going to briefly introduce some of the topics that are most popular in this field. And the recent advances, basically advances in the space robotics have been in this field of autonomy and intelligence, mobility and locomotion, sample acquisition and analysis, and etc. So let's start with that. Let's start with mobility and locomotion. So to maximize the performance and power efficiency modeling and the substantial and understanding of traction mechanics is important. So basically, to if we I mentioned about like planetary robotics, right? So if we're going to explore any particular planet and stuff like that, we really need robots to be able to move around it, so that it can do some basically excavation of that particular surface. It can collect some samples, or it can just understand what sort of crucial minerals are out there and all that stuff. So basically, mobility and locomotion is important. But the challenge is that we do not have roads there, right? We do not have people who try to who are working on memory alloys for elastic tires and all that stuff. And basically the whole objective of the research in this mobility and locomotion is to enable the rovers to go farther and faster, because currently all the rovers which we have on Mars or on the moon itself, they're quite slow. They're very slow, especially on the Mars. They're very, very slow moving rovers, and we really need them to move to be able to move faster, and so that we can explore more area in that particular given time of its service, right? And currently they move at very slow speed. So, but yeah, that's where the research is going on this wheeled robots also. And what about terrains which are quite high in structure, like the mountains or the hills or stuff like that? So there, even the wheeled robots cannot really climb up. So for that, we need limbed robots. So are you able to see this GIF here? Can you see how is it able to climb? Anyone can guess? Guys, I cannot see your chat, so you can enable your mic and speak.
Does it use suction cups?
So yeah, here it seems like a suction cup, and that is what it might be using. And there are various ways in which a limbed robot is developed, like not just like suction pumps, but also there are ways where they make it like a a spider sort of stuff, where they would they will just try to hook to that particular point of that terrain and then climb up. And then that basically, see, the terrain, it could be uneven also. So maybe sometimes these suction cups, they might not work, right? And I'm not saying like these are not the ways, but yeah, the main ways which they are currently researching on. So that is using these like hooks or stuff like that. And there is one robot, uh, lemur, Lemur, lemur or lemur. I don't know what's the correct pronunciation, but you can check it out. Its full form is basically mechanical utility robots. So there are such robots which are already being developed by NASA, and obviously they're quite expensive in nature. But it and they are working on. So you can check them out. And why we use these sort of limbed robots mainly is because wheeled robots cannot, go to slip and spin and all that sort of stuff. So we need limbed robots there. And moving forward, there thing which we need to keep in mind is that uh, these flying robots, they cannot be used in any planet. You cannot use possible because we need atmosphere to be thick. Then only it's easier to make a flying robot there. Though people in NASA, scientists in NASA, they are trying to work on making flying structures and the robots which can actually fly in such thin atmosphere also, and they are successful. So if you know about the Perseverance rover and the Ingenuity which went with it, so Mars atmosphere is not very thick. It's quite thin, I would say, and still they were successful to be able to make something which could actually fly there. So they're still working on it, but usually for objects, celestial objects like Titan, whose atmosphere is quite thick, right? So there we can send flying robots because it's easy to fly in thick atmosphere. And next one, so if we suppose, if we are trying to explore asteroids or comets, right? There we cannot even have, this wheel robots because it will, it would be, what do you say? There would be a great chance that the moment you land on that particular surface, you will just bounce off, right? So there we need robots which could, do this tumbling and bouncing and still, make a certain contact with the surface, and it won't just maybe just fly away or stuff like that, right? So for example, I will give you you know about this Ryugu asteroid, right? Ryugu, Ryugu asteroid, which Hayabusa, we had this Hayabusa mission by Jaksha to there. So suppose in that mission, if we wanted to basically explore its surface for a longer period of time, we couldn't have actually sent rovers to be there and expected it to work almost for a good period of time. So for such things, we have the stumbling or bouncing sort of robots. For celestial bodies like Enceladus or Europa that might have oceans under thick layers of ice, basically, roboticists, they have actually come up with floating or buoyant robots. So as you can see in this GIF, they are basically, just floating just below the surface of the water, and they, operate in water under the ice beds, like this NASA robot. And there is one, I think this robot itself, its name is BRUIE, Brui or something like that. Ignore my pronunciation, but yeah. So you guys can explore even this one. So if you see these images of Enceladus and which are taken by Cassini spacecraft, you can spot that there are some narrow crevices in the south polar region from where water jets are gushing out, right? So in those surfaces, we will need robots which can actually slide, or you could say gecko, right? So if you can see this robot, so in those sort of structures or terrains, we need these maybe snake-like structures and robots which can hook or slide and stuff like that. And to explore these, basically to explore these crevices and eel-like structures can also be used, or the gecko, like locomotion, and these are currently being developed to explore such terrains also. So these are just a few examples. There are many more innovative locomotion techniques to explore the unknown surfaces of these celestial objects. But yeah, these are some of the techniques which I wanted you guys to be familiar with. Moving forward now, how to make these robots intelligent, right? We do understand that robots needs to be autonomous, and for them to be autonomous in nature, they really need to be intelligent. And how to make them intelligent, first of all, right? Forget about making them more intelligent. How to make them intelligent in the first hand, right? So it's very simple, by making them more like humans. Equip them with a brain and nervous system to sense, think, and act, but not a biological brain or biological nervous system. So robots have components that include controllers, actuators, sensors, and communication unit. The sensors collect information, the controller processes the information and instructions, and transmits the command signals to the actuators. And the actuators in turn convert the signal and execute the operation. So for example, recent advances in computing allows robots to learn from their experiences, right? We are moving towards machine learning and deep learning and all that AI and stuff like that, right? Which can help them to learn themselves from their previous experiences and stuff like that. So it stores a lot of sensor data and then train the system to learn and respond. It's just like mimicking a newborn to observe its environment and remember the experiences, then respond to similar situations in the future. So you would have seen a newborn baby, most of within first 3 to 5 years of time, it learns a lot of stuff. It learns the language directly by observing their parents. It learns how to smile. It learns the difference. It starts differentiating between, the more they grow, between males and females and stuff like that. So just like a newborn baby learn from its experiences, and same way, if you're able to write algorithms in a way which can be given to the robot, then they can also become more intelligent in nature. So there's autonomy and intelligence. It's quite important, right? So giving them this ability to see, touch, hear, move, and all that stuff, and it will help them basically understanding the environment, their position. They would be able to navigate better, detect their regions of interest, and basically measuring and validating the data autonomously. Because we'll cover in the challenges, if we really try to control it remotely, like using teleoperation, there would be some delays in sending and receiving the data, right? So we need to make it as autonomous and intelligent as possible. Now, the space robots, basically, they should be capable of collecting and analyzing scientific samples. And some of the data collection techniques are optical instruments, for example, taking images in different electromagnetic spectrum, drilling, scooping, sucking, etc. So here I will show you, this is basically from the Hayabusa mission. So is this image playing? Wait. I think the GIF is not working for some reason. Let me check. Okay, no worries. But basically, I'll just explain you from here itself. So, can you see this? Some cylindrical structure here.
Yes, sir.
Yeah.
Yes,
So
yes, yes,
basically,
sir.
what does this, how does it really work is that when it, gets in touch with the surface. So actually I had a GF, but for some reason it's not playing. So basically, what it will do is it will just send a small object on the surface. It will just shoot it down so that, the dust from the surface, it will start going up. In this cylinder itself, we will just capture the samples which has been collected here. So will the capture capture the samples, and it will just again then go away, right? So basically, if you would have been able to see, if you can even see in YouTube videos, you can search about Hayabusa mission. So there you would be able to see the touchdown dynamics and collection mechanism of Hayabusa 1 that was developed in the lab. Basically, Dr. Shreya Shantre is there. So in her lab in Tohoku University itself, this thing was developed. Like her supervisor, who is there, he works on these stuff. So it uses a basically a bullet-like projectile to crush the surface and then collect those fragments that are generated by this high velocity impact. And moving forward, there are drillers, right? So we also use drillers to collect the samples. Then there are basically I wouldn't say scoopers, but rovers which can scoop out the sample to store and collect it, right? So the NASA Mars rover and lander, they are basically equipped with drilling and scooping mechanisms, right? So these are some other examples of sample collection and analysis. So I like this Hayabusa part. It's quite intelligent. Like they are not really using an arm or anything. They're just shooting down a projectile, and whatever the fragments which starts flying above, they just lock it up and they collect it. So you can do see its video. It's quite interesting. You can find it on the internet. Okay, now again a little bit break. Can you name some current space robotics mission? Anyone?
Does this include telescopes?
If they are using any space robots, then you can mention.
What about James Webb Telescope?
Yeah, it does have an origami structures. Yes. Okay.
Yes, the Sun Shield.
Yeah. But still, can
Perseverance.
Perseverance. Okay. Yes.
Perseverance.
Yes.
NASA's Viper.
NASA's
Viper.
Okay.
In 2022, later in 2022 or 24, I think.
That's a future one.
Yeah, that's future.
Okay, I'm talking about current space robotics.
Current.
mission.
Okay, the ones which are working right now.
Yes.
Then Curiosity again.
Yes, Curiosity is there. Obviously, yeah. Sadly, the opportunity is dead, but yeah, Curiosity is there. Curiosity is there. Perseverance is there. Anything else you can think of?
There was one called Pioneer, which was primarily used for clearing Chernobyl debris, which is now being used for space exploration,
Okay.
like for clearing debris and stuff.
Can you name any Indian missions? You can think of any Indian missions.
Recently, Chandrayaan 2, which was failed.
It was like it only the lander part has failed, right? So not the whole
Yes.
mission.
There was Vyomitra
There was a
for,
rover also.
There was a human AI robot which can talk. It's called Vyomitra.
Yeah, so Vyomitra, you can call it as a space-faring robot, right? So you can put them in a third category if you want. Though I'm not sure whether in general, like the current, whenever we are referring to space robotics, usually refer to human robots and stuff like that. But maybe in future they will just put it in a third category apart to which a space robot, because at the end it is a robot and working in an extreme conditions. So yes. So I'll just quickly show you some current missions. So Curiosity, as already mentioned, Perseverance and Ingenuity, Hayabusa 2. So I already mentioned about Hayabusa 1. So Hayabusa 1 and Hayabusa 2, they are not two different structures, right? Basically, it's the they have just named two different missions. So this is habit of some space agencies. I don't know why they do this, but basically, when one part of the mission is over, their objective is over. That is like they name it one, And then Hayabusa 2 is an extended mission. So basically, Hayabusa 1, it collected, that time its objective, the mission's objective was to collect the sample from Ryugu asteroid. Ignore my pronunciations. It's really hard for me to pronounce all of them. So Ryugu was the asteroid. From there, it collected the sample and it sent back in a capsule to the Earth, and it was just then also forwarded to NASA afterwards. Maybe they might had some agreement or sort of stuff like that. But in the Hayabusa 2, now it's an extended space mission. So they are targeting one more asteroid. I don't remember its exact name. It's some 1998 or 1992, some numerical name it has. So it's an extended mission which they are targeting right now. And then you might be knowing about Canada Arm. So in International Space Station, right. So see, we really do not want our astronauts to, do those spacewalks again and again, right? We want to reduce it as much as we can. And Canada Arms helps in repairing some stuff or basically servicing and etc. on International Space Station. It's a robotic arm basically made by the Canadian Space Agency, and it's still there in the International Space Station. And I'm actually quite fascinated by that. Like, I'm very much interested in Canada a lot. And there is one institute, IIAS, they're planning to, release a program in which they can, have a sort of analog mission in collaboration with Canadian space agencies. And they mentioned that they will try to teach us how to use the Canada Arm. I don't know they will let us use or no, but they will teach about that. So you guys can definitely try to search about that. And but if they release such a program, I will definitely forward it to you guys, because even I'm interested a lot in it personally. So yeah, this is like Canada Arm 2. It's a part of Canada's contribution to the International Space Station. And this is basically a 57.7-foot long robotic arm. And it was extensively involved in the assembly of the orbiting laboratories. Moving forward, what are the challenges in space robotics? So there are multiple challenges to be solved for future space robotics missions. And those who are interested in maybe starting their own company in space robotics, or maybe you want to contribute to that, or if you're looking for some problem statements or projects to work upon in this field of space robots, and what sort of problems you should target, or you just want to participate in our upcoming space science challenge in the space robotics category, and you're thinking of a problem, this is the time now. Pay attention to all the challenges which I'm going to mention, and maybe you can choose one of them to solve it. So first one is protection from harsh space environment. So now some of you might say, Shivam, you just mentioned because space has a very harsh environment, humans cannot go there, that's why we are sending robots. Now you're saying that it is harsh for robots also? And my answer is yes. Like, using robots, it does allows us to go on a longer duration space missions compared to humans, to more harsh environments and etc. But even for robots, after a certain duration or certain years of being in service, they need maintenance, right? They need protection from those harsh environments, especially the electronic system, right? So people are researching on materials like aerogel, which is a very good thermal insulator, right? To protect the electronic system. And I think NASA is already using it. I did hear in some of the documentations, but I read about it. And they're already using such materials like aerogel to protect their subsystems from the temperature variations out there. Yes, space radiation can damage the electronics. So protection from harsh space environment is one such challenge. Then mobility in different terrains. So I already mentioned about a lot of way through which you can do this. Any sort of terrain which you would have thought of. I already gave you the solution that what sort of mobility system which we can use. But all those systems, they're still in research, right? They're still proposed. Not all of them are being used right now. So we still need to develop it. We need to make it as cost effective as possible. So you guys can work on that. Mobility in different terrains. This mass and power limitation. So we can't really, launch very heavy robots. We need to make them modular in nature and make sure they don't use a lot of power. There is a power limitation currently. And though NASA is like very ahead, they are using robots, they're powering it through nuclear power basically, but nuclear power has its own implications, especially on Earth, right? So that is one such challenge you can look out for. Coming to reliability. Now, you don't want your robots to go in space and stop working. Your friend already, for example, they already mentioned about Hubble Space Telescope, right? So it was $1 million blunder, right? There was just a little, change. What do you say? Basically, the focus wasn't really, on the part where they needed it. And because of that, the images weren't as clear as they needed it, as much I have read about it. So that sort of reliability is necessary, right? That you're not doing any mistakes. So, it should not stop working after going there. And the systems must work together like systems engineer, and it must be resilient as much as possible. So that is one thing. After that, robots, human robotic interaction is another stuff which people are working on. So even by ethics, like there is robotic ethics also. It's another field. So if you go by that part also, so people say that robots should not be treated as slaves, right? There should be proper cooperation between robots and humans for enhanced output. And we can use technologies like haptics to control the robots for using teleoperation and stuff like that. So basically, we can wear something in our hand and then try to control our robots remotely and see what the robots are seeing and all that sort of stuff. But it has their own challenges, which I'm coming to remote operations. So suppose if you have a robot on Mars and you want to control it from here from Earth. Now the major problem is there is delay in receiving the signals and sending the signals. And for Mars, I think it would be easily 8 to 16 minutes if you transmit a radio signal from here and try to receive the same, right? So those signal delays doesn't really, it does not make it feasible. So you can work on various other sort of communication systems, like optical communication systems. But in optical, another problem is that your range in which the signal could be received, that decreases. In radio signal, you have quite a large area to cover, but then the signals they reach, they get weak by the time it reaches to that point. So you need to come up with a hybrid system of using this lasers and radio waves to make better transmitters and receivers. So that is there. And then the next challenge is autonomous capabilities. So I already told you about artificial intelligence, ML, and what not we are trying to do to make our robots intelligent. But we need more intelligence for it to be really autonomous. We really need them to learn from their experiences in a much better manner. Theoretically, we have we have ways to do that, but to actually execute it, it's a challenge, right? Whenever we say that, okay, this problem is there, we can solve it through the AI. Now, AI is not a Pandora box or a magic box. There is actually a person behind computer writing codes and algorithms, right? So you cannot just say that we will use the AI and we will do that. You need to build that AI. You need to build that sort of algorithm to make it more intelligent. And that's hard. That's a challenge to be worked upon. So those of you who are interested in AI and stuff like that, so you can start working on it. Then next challenge is testing and qualification. Now on Earth, we do not have, we do not really have, space-like environment. So we won't know that our robot is really qualified for space until and unless we really launch it. So we won't know that, right? So until unless we don't launch our robots, we really don't know whether it is qualified for space. And to test it on Earth, make bigger facilities, we need to come up with various simulation methodologies and stuff like that, and they are quite expensive. They are very expensive, and for that reason, it's again testing and qualifying a robot for space is quite a challenge. So you can come up with various innovative methods to make sure we are able to do that in a much cheaper manner. Forward, we have swarm and multi-agent exploration. So basically, currently all the robots which we send to space, they are big robots and stuff like that. But we are working on small robots, right? Basically, multiple small robots which can be used for exploration, like lunar excavation or trying to understand the surface. And though it's a great solution, but it increases the complexity of control and path planning. And communication is a challenge here, right? Methodology through that itself for achieving the mission objectives, that is a challenge. So that is another research area which is quite hot, and you can work on it. Next is modular robotics. So modular robotics is basically solution to sending big robots and stuff like that. We can send small robots one by one, and then they can assemble there and stuff like that. So it's a solution, but again, building that solution is a challenge, right? So modular robotics is another hot topic apart from swarm intelligence to look out for. Then self-repairing robots, as we already mentioned about Hubble and stuff like that. So we need, it's a necessity that in case of software failures or stuff like that, our robot should be able to reboot itself. It should be able to debug itself. Humans can't always go to fix such stuff. So for example, what do you say? If we send humans to, for each and every servicing or each and every small problem, it might be a very small problem of just repairing a, connection between, 2 points, just, changing the circuit or stuff like that. But it could cost a lot, and it could also be risky for humans to do that, right? So we need self-repairing robots, shape-changing and origami robots. And as one of your friends mentioned, that in JWST we use that origami stuff, right? So we are working on it. NASA and all that stuff. They are working on such robots, and other institutes are also getting to it very fast, right? So basically, origami. Those who don't know what origami is, it's basically a Japanese method to fold papers and to make animals or birds and stuff like that. So that is about shape changing and origami robots. And at last, in situ manufacturing and services, right? So suppose if you want to build habitats. So for building habitats, we can't always get supplies from Earth. We need to make houses ourselves. We need to manufacture, right? And how we will do that? We will do it using lunar soil or regolith, and to execute it, we need robots, right? So that is the last challenge which I wanted to mention about. And yes, if you're able to solve them, it's a great way to enter into the space robotics industry. Now, can you name some future space robotics missions? Anyone?
Actually, India is launching Gagagyan.
Yeah, so Gaganyaan, basically, it's a human expedition mission. In part of the Gaganyaan, we have Vyomitra, and itself is not a space robotic mission.
NASA is planning to launch Dragonfly in the year of 2027.
Yes. A very good example. I will come to that.
And NASA is also planning to launch a rover for Triton in 2030, I guess.
Okay, yeah, cool.
Can
Anyone?
Starship be considered as a space robotic mission?
So see, these are like actually big spacecraft. So obviously we are using robotic technologies in that. But you need to understand, like when we refer to space robots, what sort of robots we are referring to. Robotic technologies will be used in each and everything. But when we say talk about space robots, then right
I
now,
meant the landing mechanism.
yeah, okay, yep. So I'll just show you some missions here. So how many of you know about this DART mission? It's quite interesting, basically. Anybody? This mission is basically, for any future threat to the humanity by asteroids. So this DART mission is looking for redirecting the asteroid in a different direction. So they will just maybe bombard that spacecraft to that particular asteroid and try to redirect its path, and that is what DART mission is all about. And yes, Samprit, you want to add anything to that?
Sorry, nothing.
Okay, so you raised a hand.
Actually, it was double asteroid redirection test, right, from NASA.
Yeah, that's the full form of that. But means that same thing, like to redirect the particular asteroid in a different direction, and we're trying to test such technologies, and we are doing such missions so that in future, if there is any threat by an asteroid to Earth, we will be able to protect ourselves. Then, as your friend already mentioned about Dragonfly, right? So Dragonfly, it's a mission to Titan, and because there we have a very thick atmosphere, we can have a flying structure, flying robot there, right? And that's why you can see it's this robot can actually fly. So these are some very exciting missions. ExoMars is also there. ExoMars is basically this would be the first, this would be the very first time when we will try to dig into the Mars 2 meters down. So in all other missions, at the max we went to, what do you say? We just digged around some centimeters, like 10, 15 centimeters. But this would be the very first time where we will try to go 2 meters deep and then understand the geological structure, how this whole ancient life possibility which we think means not about the life in general, but basically the geological history of Mars is something which we can understand. So in your school days, if you guys would remember that there were certain methods, I don't remember exactly, but I just could relate to it, that if you're able to get the whole soil sample in from the much depth, the parent soil and topsoil and all that stuff, from there you can understand how this geological structure was developed and all that stuff, like that. So basically we have our astrobiology people in Spaceonova, so they are quite knowledgeable about it. They're into geology and all that stuff. So I can talk to them, but you can check about this mission on internet. So it's significance is that it's going to dig 2 meter deep in 2022. So yeah, these are some exciting missions coming around recently in 2022, 2024, and 2026. And at last, I will also talk about new space robotics in general. So those who want to be entrepreneurs and you want to be founder of some space robotic companies, right? So you in general also need to understand the market, right? That what is the current market and what's going on right now. So we keep saying how to make space accessible to all, and gradually robotics is becoming part of the new space ecosystem, right? So public-private partnerships are becoming a forefront of space exploration. Like the public companies, they are making more compared to the government companies, right? So the commercial segment is expected to basically depict a higher growth against the government one in this coming decade. So one best example is the Google Lunar X Prize Challenge that ran from 2007 to 2018, and it called for privately funded teams to be the first to land a robotic spacecraft on the moon. Although there was no winner announced in that, the challenge, it really gave birth to many spin-off companies like iSpace, Astrobotics. There was this team in this from India, and then Japanese iSpace. And though they failed in that challenge, they couldn't build the required rover and basically the whole robot in the given time frame. But they are at a good position right now. So Japanese iSpace is now building landers and micro rovers to be launched in next couple of years. The American Astrobotic has deals with NASA to provide commercial lunar payload services, which is to be launched, later this year. Or I think it has been already launched. I don't know really about the fact. You can verify it once. And the Israeli organization, the Space IL, it attempted to land on Moon in 2019. And the Hungarian Police Space Technologies are developing innovative rovers for lunar surface exploration. So apart from that, the satellite servicing segment is basically estimated to remain dominant with the escalating demand and requirement for space-based services such as satellite servicing, deorbiting services, surface mobility, and resupply missions, and all that stuff. And debris removal and mining of near-Earth asteroids are some of the exciting applications for commercial robotics. Though in India, if you want to start a company for space debris removal, it could be a little difficult because government factor is there. But yeah, overall in the world, it is being worked by the private space companies also. And entrepreneurs can participate in national and international accelerator programs to kickstart their startups. Make it in India, new space ecosystems in India are providing great opportunities to jump into this field, and you can have your own innovative space robotic companies that will eventually contribute towards India's space advancements. And currently in India, fundamental space robotics are developed by ISRO and DRDO, but I would say the scope of committing to a space robotics based startup is high. In coming years, we will get to see some space robotic startups, and SpaceOnova itself is working on a, you could say, secret project right now. If it's successful, we will reveal it soon in the public. And I'm expecting that at least 2 to 3 startups will start coming up in this field in coming 5 years. There is already one startup based from IIT BHU right now who's working on lunar excavation and all that stuff. So yes, that is about the market in general. And I would say stay updated with the space industry and academia. Both space and robotics are interdisciplinary and can accommodate a number of disciplines like mechanical, automation, electronics, computer science, information technology, and develop the logic and system thinking to solve different personal challenge, which has been launched by the second edition has been launched by SpaceOnova, and will soon try to collaborate with you guys also. And this will really help you all to get an exposure to solving problems and learn during the whole challenge itself, right? So, and also join organizations like not just SpaceOnova, maybe SGSC, Robotics Society of India, IEEE, Robotics and Automation Society. Join them, right? And build your networks, subscribe to the newsletters. And this is a link if you guys are interested in higher studies in space robotics or want to do your master's and PhD and stuff like that. So Dr. Shreya, she has made a file for you guys. You can scan it or just take a screenshot of this basically whole slide. Just take a picture, and then you can just scan this particular QR code and go to that link. You can access this resource. It will be really useful for you guys. It also consists of scholarships which you guys might get. So yeah, with this I will end our session, and if you guys have any queries and concerns, feel free to ask me. And if you guys want to ask afterwards, you can post them on spacenova.com/discord. You can just directly reach out to me through the group itself. And stay tuned to us as we create a space ecosystem where limit tends to infinity. Thank you, guys.
Uh, Thank you so much, Shivam, for taking that amazing session. And all the participants as well, thank you so much for joining. Please don't forget, this is just day one. Tomorrow, same time, 7:30 p.m., we'll be having our day two of this space robotics workshop, where they will be teaching us about ROS. Once again, thank you so much for joining. The session's over for today. You guys can leave.
You can ask your questions if you want to.
Oh yeah, that's also that. Sorry. Yeah, if you have any questions, you can.
Yeah. So you can ask any. Mayuri mentioned any online courses we can take up to learn about space robotics. So guys, with Shreya Shantra, so we are launching a space robotics training program on March 6th. So you guys can look out for that. We'll soon send you guys information. Maybe to people here at SEDS-VIT itself. So you guys can ask from them, and you can definitely enroll in that. You'll get research support and stuff like that. So yeah, we'll send you the information. Check that out. And otherwise, you can also check out Coursera or other companies also if they have any space robotics stuff. And feel free to explore. We are like doing our part. You can explore anyone.
Yeah, along with that, I'd like to just let's just take over the stage for a few more things. That is for tomorrow. We'll be going into ROS, that is a robotic operating system. So we'll be diving deep into it. And yeah, there are a few things which we would ask you guys to come prepared. Okay, and so that is why we'll be releasing or we'll be sending you a handout just before the session. So I'll be first of all, I'll be telling what are the basic things you'll be needing. You'll be needing an Ubuntu system. Okay, and in that Ubuntu system, we are expecting you to install the ROS, that is Robot Operating System, the ROS Noetic version on your Ubuntu systems. All right, so no need to worry about that. We'll be sending you a handout containing all the information, all the tutorial, all the steps to be followed, so that you guys come prepared for tomorrow's sessions. But as an advance, I'm just informing you that you need an Ubuntu system for ROS to learn. Okay, and it should be a Ubuntu 20.0. I mean, that is the latest version. So yeah, it should be more than Ubuntu 20. That is the version which we are requiring. In case you are or you want to stick with Windows only, I mean, that's not recommended, but yeah, you can go ahead on Windows itself. If you're having Kali and you want to try ROS, you can do, but there are few complexities. There are a few.
Guys, go with Ubuntu. Please don't try anything else. It's very complex.
Yeah, I mean,
Go with.
yeah, I mean, if you want to try Kali, but there are some complications in Kali, so you can go ahead with that. But my recommendation is for Ubuntu, and Ubuntu you can either go for dual boot or you can go for virtual machine. That is the two things. ROS on Mac, I mean, Bhardwaj, you need to install a virtual machine for that. For Mac, it's not there at all. So you need to have a virtual machine, and that virtual machine you can then run ROS easily, happily. Okay, and we'll be doing that. Okay, so that is the thing. Yeah.
One slight request. Can you keep suppose you have to install of these systems, can you keep an hour before the actual lecture time and help us throughout that process?
Swati will send you all the details today itself in the WhatsApp, so you guys can just follow that steps, and you would be ready to go with.
Yeah. No, actually, I was requesting more on the line. Suppose we are starting the course at 7:30. So can we all meet on the meet on around 6:30, so that if any doubts, we can real time, just finish off the installation process. Because last time I tried, my system crashed. So I'm a little nervous about installing Ubuntu and all of that systems.
I mean, yeah, it normally crashes if you're having a small RAM or if you're installed, if you're
try it through the virtual box instead of directly installing it. So use the virtual.
I mean, that would be preferable virtual machine, but dual. If you want to go for dual boot, it's a complex process, but it's also a thing, and it will run rather smoothly. Virtual machine may lag, It depends on your system, to be really honest. What is the RAM capacity? What is the processor speed? So on all these factors, it depends how well your system would run. Okay, but yeah, you do need a virtual machine. That is what I'm guaranteeing you. Okay. So I'll be sending you the tutorial. No need to worry about that. I'll be sending you all the detailed things, steps which you need to be following throughout. And in case you're ever stuck or anything, feel free to reach me out and I shall be trying my best to clarify or make sure that the system is running.